You know, the AI revolution is happening all around us, but it has this massive secret hiding in plain sight. It's incredibly hungry for electricity. Every time you use something like ChatGPT or an AI-powered search, you're tapping into data centers that are pushing our power grids to their absolute limit. So the big question is, where is all this energy going to come from, especially if we want to stick to our climate goals? Well, the answer might just surprise you. All right, so here's how we're going to break this all down. First, we'll get into the real scale of AI's power problem. Then, we'll look at the surprising nuclear revival it's sparking. After that, we'll explore a totally new kind of nuclear reactor, but we'll also face the very real challenges standing in the way. We'll tackle that huge safety question, and finally, we'll imagine what this AI nuclear future might actually look like. So, first things first, we really need to wrap our heads around just how enormous this energy challenge is. Seriously, it's a problem on a scale the energy sector hasn't really had to deal with for decades. Just look at that number, 945 terawatt hours. I mean, what does that even mean? Well, to put it into perspective, that's more electricity than entire countries like Argentina or Sweden use in a whole year. And that's just the projection for what data centers will need by 2030. It's an absolutely staggering figure, and it's forcing a complete rethink of our entire energy system. And what's really wild here isn't just the number itself, it's the speed. We are not talking about some slow, gradual climb over the next 20 years. We're talking about energy demand more than doubling in less than a decade. And almost all of that explosive growth is coming from one place: artificial intelligence. And look, it's not just about needing more electricity. It's that AI needs a very specific kind of power. It has to be super dense, totally reliable, and running 24/7 without a single interruption. Our electrical grids just weren't built for that kind of intense, constant demand. It's becoming a huge bottleneck, so much so that some new AI data centers are actually getting delayed simply because they can't get hooked up to the grid. So this incredible, almost shocking level of demand is forcing the biggest names in tech to look at an energy source that, let's be honest, many people thought was a thing of the past: nuclear energy. And I want to be clear, this isn't just some idea being floated around. We're talking about the big players: Microsoft, Google, Amazon. They are actively signing deals to power their huge data centers directly with nuclear power. They're scrambling to get their hands on reliable, carbon-free energy to fuel AI's growth while also trying to meet their own net zero promises. This all boils down to a really important concept in the energy world, something called firm power. Now, renewables like solar and wind are amazing, but they have a catch: they're intermittent. The sun goes down, the wind stops blowing, but AI can't just clock out. It needs constant, dependable power. And that's exactly what nuclear provides. It's firm, 24/7 power. And that is absolutely essential for these operations. So, when we talk about a nuclear renaissance, what are we actually talking about? Because it's not what you might be thinking. We're not talking about those giant old-school plants from the 20th century. This is about a whole new, much more nimble approach to atomic energy. Yeah, this slide right here really lays it out perfectly. On one side, you have traditional nuclear, massive projects that take decades to build, cost billions of dollars, and take up a huge amount of land. And on the other, you have these small modular reactors, or SMRs for short. The idea here is totally different. You build the parts in a factory, and then you just assemble them on site. They're smaller, cheaper, and way more flexible. You see, SMRs are almost tailor-made for what AI needs. They can power a data center directly, which means they don't have to compete for energy on the already strained public grid. You can literally add new reactor modules as your AI campus gets bigger. And you get that critical, weatherproof power on a much smaller piece of land, which is a massive advantage compared to a huge solar or wind farm. Okay, but this all sounds a little too good to be true, right? And you'd be right to think that. This is not a silver bullet, and we have to be realistic about the massive roadblocks that are still in the way of this nuclear-powered future. I mean, look at this. The challenges are coming from all sides. You've got the regulatory side, the permits and approvals, which can take, seriously, a decade or more. Then there's the money, the massive upfront cost to build these things. On top of that, you have to win over the public, make sure there's a stable supply of nuclear fuel, and find enough people with the specialized skills to actually build and run these plants. None of these are small problems. And all of this leads to a pretty sobering dose of reality. The bottom line is, For the next few years at least, new nuclear just can't get built fast enough to keep up with AI's insane growth. So, in the short term, that energy gap is going to be filled by a mix of everything else. More renewables, big batteries, and yep, natural gas. Right. So all of this talk about a nuclear revival inevitably brings us to the elephant in the room, the question that's probably on your mind right now. Is it actually safe? And look, we can't have this conversation without talking about Chernobyl and Fukushima. It would be completely irresponsible not to. Those events are burned into our collective memory for a reason. And understanding what went wrong back then is absolutely key to understanding how much the technology and the entire approach to safety has changed since. So what's changed? Well, the single biggest leap forward is a concept called passive safety systems. And honestly, this is a total game changer. Modern reactors are designed to be walk-away safe. Instead of needing active pumps, outside power, and human intervention to stop a meltdown, they use the basic laws of physics, things like gravity and natural heat circulation, to shut down and cool themselves all on their own. No power or people needed. And it's not just one single fix. Modern safety is all about having layers upon layers of protection. Think of it like a fortress. It starts at the microscopic level with new kinds of fuel that can withstand insane temperatures. It includes reactor designs where a runaway reaction is physically impossible. And the whole thing is wrapped in tougher post-Fukushima regulations and those incredible passive safety systems. Okay, so let's shift gears and look to the future. What happens when you take these two incredibly powerful technologies, AI and new nuclear, and they start to feed off each other? Well, first, the relationship is pretty straightforward in one direction. To put it simply, nuclear gives AI what it desperately needs, that constant, clean, 24/7 power that will allow it to keep growing without completely destroying our climate goals. It's the energy foundation for the next wave of the AI revolution. But here's where it gets really fascinating. It's not a one-way street. The relationship goes both ways. AI can actually be used to make nuclear power better. We're talking about using AI to optimize how plants are run, to help design new and more efficient reactors, and to constantly monitor systems to make an already safe technology even safer. So what you get is this incredible feedback loop, a truly symbiotic relationship. Nuclear powers AI's growth, and AI makes nuclear better, faster, and safer. Each technology pushes the other one forward, creating what could be a powerful cycle of innovation in both clean energy and in computing itself. Which leaves us with a big question, right? Will the AI revolution be powered by a nuclear one? It really feels like a race is on. A race between AI's explosive need for power and the nuclear industry's ability to overcome some very real challenges and actually deliver. The choices we're making right now about our energy grid won't just shape the future of technology, they're going to define the future of our climate.